welcome back. So in today's lesson we are doing 7-1 and we're focusing on ratios and similar polygons. And ratios is something that hopefully you've learned before. A ratio compares two different objects to one another. So the word you want to focus on the most though is the word similar. Similar means, in mathematical terms, means the same shape but not necessarily the same size. So when I look down at my triangles here on the left, I have triangle 1 and triangle 2. They are the same shape, but they're not necessarily the same size, and that's what it means to be similar, which is different from what we've been learning a lot before, the word congruent. So similar means same shape, but not necessarily the same size. So these two are similar. So down at the bottom, it says triangle 1 is similar to triangle 2. And then I wrote my similarity statement. Triangle 1, this little squiggle mark means similar, is similar to triangle 2. And over here on the right, I have two triangles, but they're not exactly the same shape. So triangle 1 is not similar to triangle 2, and then I wrote my similarity statement down at the bottom. So now let's take it one step further. So I have two shapes down at the bottom, and we're going to talk about similar polygons. So you already discussed that similar means same shape, but not necessarily the same size. So similar polygons take it a step further, and it says that similar polygons are polygons whose corresponding angles are congruent and corresponding lengths or sides are proportional. So let's go through each one. If you want to follow along in your book, I'm on page 466. So let's check out the corresponding angles first. Corresponding means they are basically in the same spot in each shape. So if I look at a smaller trapezoid here, ABCD, and I'm looking at angle A, the angle that corresponds to angle A in the larger trapezoid, EFGH, is E. So they are both the same angle, they're both congruent, so that one checks out. Then B goes with F, D corresponds with H, and C corresponds with G. So we have one step done. So all the angles correspond to each other. Now we have to find out if all the lengths are proportional. So what I'll do is I'll first look at AB. And when I look at AB, it corresponds to side EF. So I'll write 6/12. When I reduce that, it comes down to 1/2. Then I look at my next set of corresponding sides. I look at BC is 5.4, and then FG is 10.8. That's its corresponding side. So now I have 5.4 over 10.8. That also comes down to 1/2. Then I look at my next two corresponding sides. I look at CD, and that's 4, and its corresponding side is GH, and that's 8. That also reduces down to 1/2. And then I look at the last one, DA, and that corresponds to HE. So 5/10, and you guessed it, that comes down to 1/2. Okay, since all of the corresponding angles are equal or congruent, and then all the corresponding sides are of the same proportion, 1/2, then these two trapezoids are considered similar polygons. So let's check our first example. Example 1 says, identify the pairs of congruent angles and corresponding sides. So that makes it pretty easy. So if I look here, I have angle A corresponds to angle J, angle B corresponds to angle G, and angle C corresponds to angle H. So I can see that B is 90, G is 90, C is 59, H is 59. And even though they don't tell us A and J, we know since these two are the same, then these last two have to be the same as well. So then I'm going to write that out. I'm going to write out, so angle A is congruent to angle J, angle B is congruent to angle G, and angle C is congruent to angle H. Now I have to make sure that all the sides are corresponding, or all the corresponding sides are proportional to each other. So I'm going to look at my first set, and I look at AB, and that corresponds to JG. I'm going to rewrite that here. AB and JG gives me 10 over 5, and it's like saying 10 divided by 5, which reduces down to 2. Then my next set of corresponding sides is 11.6, or I'm sorry, AC, and then GAH. So that's 11.6 or AG first, or AC, sorry, over JH. So 11.6 over 5.8. That also comes down to 2. Then I check my last set. BC corresponds to GH. So that's 6 over 3. It's like saying 6 divided by 3, which also equals 2. So I have 2, 2, and 2. So they're all proportional to each other. So this one checks out. So after that, we need to understand what the similarity ratio is. The similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So I look down at the bottom, and I'm already assuming that these two polygons are similar. I look at the angles first. All the angles of the corresponding angles from triangle ABC to DEF are all equal. Then I look at the sides, and then I determine if they're proportional to each other. So AB is 3 and DE is 3. So AB goes with DE, so 3 over 9. Then, which that reduces down to 1/3 actually. Then I have my next set, AC. This corresponds to DF, which is 3 over 9, 1/3. And the last one, most obvious, BC. Last but not least, BC goes with EF, 3 over 9, and 1/3. So if they ask me the similarity ratios between the two, then I would just say that it is 1/3. Example 2. Determine if JLM is similar to triangle NPS. If so, write the similarity ratio and a similarity statement. So when I look down at the bottom, first I have to determine if the angles are similar to each other in both triangles, or congruent, I'm sorry. So I look at the larger triangle, JLM. L corresponds to P, and they're the same measure. Angle M corresponds to angle N, and they're the same measure. And then J corresponds to S, because these two are the same, and these will be the same as well. So that part of the similarity check works. So then I have to make sure they have all the corresponding sides have the same ratio. So I've got my calculator ready. I'm going to look at JL, and that corresponds to PS. So I have 75/30. And that equals 2.5. Then I have JM, and that corresponds to SN, so 45/18. That also equals 2.5. And then my last one, LM over PN, and that's 60/24. When I divide it, I get 2.5. So my similarity ratio for this is 2.5. If I had left it in fractional form, you could also put 5/2. That also works. So in this one, are the triangles similar? Yes. All the sides are proportional, and all of the corresponding angles are congruent. So then, when I write my similarity statement, I'm going to write triangle LMJ is congruent to triangle PNS. And the similarity ratio is 2.5 or 5/2. Last example. Example 3 says a boxcar has the dimensions shown. A model of the boxcar is 1.25 inches wide, so I have to find the length of the model to the nearest inch. So in this last example, we can assume that the boxcar is similar to the model, or vice versa. The model is similar to the boxcar. So if that's the case, we set up proportions just like we did in the other problems. So, or ratios. So when I look at it, I'm actually going to set up a proportion because I want to be able to find out what x is. So when I look at here, the boxcar, the top, 36.5 feet corresponds to x inches. So I'm going to put 36.5 over x. And then I look here on the boxcar, and the side of 9 feet corresponds to 1.25 inches. So 9 over 1.25. what I want to do is I want to cross multiply. So I can cross multiply x and 9. So I'll have 9 times x equals, and then I want to cross multiply here. So 36.5 multiplied by 1.25. When I multiply the other side together, so 36.5 times 1.25, I get 45.625, and that equals 9x. I'm going to divide by 9 on both sides, and I get approximately, because it told me to round to the nearest inch, 5 inches.